Welcome to Section 3.3, Part 2. This is the 28th session of the ISACA CISA exam prep series. This part picks up where the last one left off. Now we'll cover the methods, tools, and acquisition behind development. We'll answer several questions. What are the main development methods beyond the basic life cycle? How do reengineering and benchmarking improve processes? Which tools boost developer productivity? And how do you acquire infrastructure, hardware, and software well? Why does this matter beyond the exam? Because most systems today are assembled and bought, not hand-coded. Picture an insurer modernizing its claims platform. The team mixes components, web services, and a vendor package. Each choice carries its own controls and its own risk. When you know these methods, you know what to test. And when you know acquisition, you protect the contract and the data. Let's start with development methods. What is prototyping? It's quickly building a working model to test ideas. Users react to real screens early, which reduces risk. But watch the downsides. There's pressure to ship an unfinished prototype. Extra features creep in beyond the original requirements. And controls like backup, security, and audit trails get missed. Change control also gets messy and undocumented. So what is rapid application development? It builds important systems fast while keeping quality. It uses small expert teams, prototypes, and tight time limits. It moves through 4 stages: concept, functional design, development, and deployment. Prototyping is its core tool, whatever the technology. And what is agile development? It assumes you can't define everything up front, so it works in small, time-boxed iterations called sprints. The team replans after each one. It leans on people's knowledge over heavy documentation. Teams stay small, mixed, and close together. And the project manager becomes a facilitator, not a controller. Scrum is the best-known agile method. What is object-oriented development? It groups data and the procedures that act on it into objects. The data are attributes, and the functions are methods. Objects come from templates called classes. A subclass inherits from its parent, that's inheritance, and the same message can behave differently across objects. That's polymorphism. A common notation here is unified modeling language. It helps visualize complex object-oriented designs. Remember, it's a programming technique, not a full methodology. Closely related is component-based development. You assemble applications from pre-built software pieces. They talk through defined interfaces, whatever language they use. The payoff is faster delivery, better quality, and easier reuse. But there are risks. Components may not interoperate cleanly. Reliability can drop, and the attack surface can grow. And licensing many components gets complicated. How does web-based development tie systems together? It standardizes how code modules integrate across platforms. It leans on a markup language to describe data. 3 pieces work together here. One protocol defines the interfaces and carries the messages. One description language identifies the service and its message formats. And one directory lets others discover available services. The big win is loose coupling. Change one component and the others usually don't break. What if you're updating an existing system, not building new? Then think about reengineering. Software reengineering reuses an old system's design and components. One flavor is business process reengineering. Another is a service-oriented approach built on reusable services. A different idea is reverse engineering. Here you study a finished product to learn how it works. You might decompile its code or test it as a black box. It can speed development and reveal improvements. But be careful. Licenses often forbid reverse engineering outright. How do development and operations work together? That's the idea behind DevOps. It merges development and operations to remove friction. That brings benefits, but it also reshapes your controls. So watch separation of duties closely. DevSecOps goes further. It builds security into the pipeline from the start. That promotes security by design and fewer vulnerabilities. Let's go deeper on business process reengineering. What is it really about? It's redesigning processes to respond to pressure and cut cost. Usually, that means automating away manual steps. The path is straightforward. Define the area, understand the process, then redesign it. Implement, monitor, and keep improving. But here's the audit concern that matters most. Key controls can get re-engineered out of the process. Your job is to find those controls and flag the impact. If a key preventive control is being removed, management must accept that risk knowingly. A related discipline is benchmarking. It compares your processes against recognized leaders. It runs through a clear cycle. Plan, research, observe, analyze, adopt, and improve. The whole point is continuous improvement. Which tools boost developer productivity? Start with computer-aided software engineering. These automated tools support the development process end to end. They split into 3 tiers. Upper tools capture requirements. Middle tools handle detailed design. Lower tools generate the actual code. A caution though, these tools speed design, but they don't guarantee it's correct. So secure the repository and keep strict version control. 2 more aids round this out. Code generators produce code from defined parameters, and 4th-generation languages cut effort and cost. They're non-procedural and often portable across platforms, but they lack the low-level control for data-heavy work, so weigh them carefully against traditional languages. Now let's shift to infrastructure. How do you choose a physical architecture? No single platform meets every conflicting requirement, so you make a formal, reasoned choice, not a price-only one. The analysis runs through phases. You review the existing architecture in a first workshop. You capture constraints like power, space, and physical security. Then you design, draft functional requirements, and select vendors in parallel. Why run a proof of concept? To prove the chosen hardware and software can actually deliver. You build a running prototype in simplified form. It demonstrates security, performance, and basic failover. Then you plan the rollout in a phased, iterative way. Requirements analysis keeps feeding the process throughout, and procurement starts service-level management and signs the contracts. How do you acquire hardware and software? You start with clear specifications for vendors. Often that's a request for proposal or an invitation to tender. The specs cover processing needs, hardware, software, and support. Then you compare bids against requirements and each other. You check the vendor's finances and support capability. You verify the hardware isn't from grey market sources. And you review the contract terms and the right to audit. You also score vendors on defined criteria, things like throughput, capacity, compatibility, and response time. What's special about acquiring system software? You weigh business and technical needs together. Cost, compatibility, security, and future growth all count. The software might be generic, customized, custom-built, or cloud-based. A project team writes the request and distributes it widely. Sometimes a request for information comes first to gather advice. You then score and rank the responses objectively. Shortlisted vendors give scripted, scenario-based demonstrations. A conference room pilot lets users try the system hands-on. Talk to current users about reliability and service. Then negotiate and sign, with legal counsel reviewing first. Make sure source code escrow is covered if needed. So where do you fit in software acquisition? You confirm adequate security controls before any deal is signed. Without them, data integrity is hard to assure. You check the request covers the right items. You confirm the chosen vendor matches that documentation. And you make sure legal reviews the contract before signing. So let's bring it together. Prototyping, rapid development, and agile trade structure for speed. Objects, components, and web services favor reuse and integration. Reengineering and benchmarking sharpen existing processes. Just watch for controls that get re-engineered away. Productivity tools speed the build but need version control. And disciplined acquisition protects cost, security, and the contract. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.